This is Bob Capetta from the College of the Florida Keys, and this is Intermediate Algebra Final Exam Review, starting with problem 11. So this time we're going to begin with the following problem. We want to complete the square. For x squared minus 4x minus 13 is 0. X squared minus 4x minus 13 is 0, and our goal is to complete the square, so we're going to add 13 to both sides. So I get x squared minus 4x equals 13. Now we need to complete the square. So how do I do that? Well, I draw a square so I can complete one. And what do I do? I have x squared minus 4x. So x squared goes here, and these two boxes have to add up to negative 4x. So negative 2x here, and negative 2x here, which will give me x times x to give me x squared. X times negative 2 gives me negative 2x. X times negative 2 gives me negative 2x. But how do I complete the square? What's this last cell? Negative 2 times negative 2 is positive 4. So I'll add 4 to both sides to complete the square. So what I have with this box is I have x squared minus 4x plus 4 equals x minus 2 times x minus 2, or x minus 2 squared. So the left-hand side here is x minus 2 squared. The right-hand side is 13 plus 4, which is 17. So now let's take the square root of both sides, which really gives you absolute value. But I'm going to go ahead and say write that as plus or minus the square root of 17. So if that's the case, I get x minus 2 is plus or minus root 17. Add 2 to both sides. X is 2 plus or minus root 17. So I have two answers, which is what I normally get. If I have a quadratic equation, we typically have two answers to our quadratic equation. So our two answers are 2 plus root 17 and 2 minus root 17. Those are not rational answers, but they are real numbers. Our next example may not be real numbers. So for this one, we're going to use the quadratic formula to do this. So x squared plus 2x plus 5 equals 0. So let's put a 1 in front of the x squared. We will need that to determine our a. So what we have here is we have a is 1, that's the coefficient on x squared. B is 2, that's the coefficient on x. C is 5. Now what's our rule? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times 1 times 5. So I get x is negative 2 plus or minus the square root of 4 minus 20 all over, it looks like I forgot my all over up there, 2 times 1, all over 2. So I get x is negative 2 plus or minus the square root of negative 16 over 2. Now what about the square root of negative 16? Well, that's the square root of negative 1 times the square root of 16. That's I times 4, or 4i. So this tells me that x is negative 2 plus or minus 4i over 2, which I should break down into two fractions. Negative 2 over 2 plus or minus 4i over 2 equals x. So x equals negative 1 plus or minus 2i. So one of my answers is x is negative 1 plus 2i, and the other answer is x is negative 1 minus 2i. So my two answers are going to be negative 1 plus 2i and negative 1 minus 2i. Again, that was a quadratic equation that required the quadratic formula, although I could have solved it by completing the square. All right, next we have another one that's asking us to use the quadratic formula. I have 3x squared equals negative 8x minus 2. That's an equal sign. So if I'm going to use the quadratic equation, I need all of the variables on the same side. So add 8x to both sides, 3x squared plus 8x. Add 2 to both sides, plus 2 equals 0. So if this is the case, then a is the coefficient on x squared. A is 3, b is the coefficient on x, b is 8, c is the constant, c is 2. So my equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what do I get? I get x is negative b, I get x is negative 8 plus or minus the square root of b squared of 8 squared minus 4 times 3 times 2 all over 2a all over 2 times 3, which is negative 8 plus or minus the square root of 64 minus 12 times 2 is 24 all over 6. So I get x is negative 8 plus or minus the square root of 40 over 6. Now what about the square root of 40? Well, it's probably simplest to think of root 40 as root 4 times root 10. Root 4 is 2, so it's just 2 times root 10. So knowing that, I get x equals negative 8 plus or minus 2 root 10 over 6, which is negative 8 over 6 plus or minus 2 root 10 over 6. And then I get x is negative 4/3 when I reduce that fraction. Plus or minus 2 over 6 becomes 1/3 root 10 over 3. So I have two answers. I like to use curly braces. We'll have negative 4/3 plus root 10 over 3. And we have negative 4/3 minus root 10 over 3. Is that one. So our next question is an algebraic fraction. We want to simplify x squared plus 5x plus 6 over x squared minus 1. So let's take a look at that. X squared plus 5x plus 6 over x squared minus 1. So I need to put them in the factor box and see what my result is. So x squared plus 5x plus 6. Let's see what we get there. Here's x squared, here's 6. Here's plus 5x. I believe that'll be x times x plus 3 times plus 2 plus 3x plus 2x is plus 5x. So I get x plus 3 times x plus 2 on the top. And on the bottom I have x squared minus 1. And let's see what we get there. And again, this is question 14. X squared minus 1, so the middle term here is 0x. X times x, negative 1 times positive 1. Negative 1x, positive 1x is 0, so I get x plus 1, x minus 1. But notice, nothing cancels. So in a sense, that's my final answer, or frankly, in a sense, this is my final answer. The fraction cannot be reduced. Nothing divides out in that example. Okay, next we are asked to divide some algebraic fractions, and that is question 15. we have x squared plus x over 3x minus 15 divided by x squared plus 2x plus 1 over 6x minus 30. So the first thing to do is to recognize if we're dividing, we need to invert and multiply. So we'll change this to x squared plus x over 3x minus 15 times 6x minus 30 over x squared plus 2x plus 1. Now we're multiplying these algebraic fractions. Let's factor. X squared plus x, there's a common factor of x. Let's extract it. That's x times x plus 1. 3 times x minus 15, common factor of 3. 3 times x minus 5 times. 6 times x minus 30, a common factor of 6, times x minus 5. And x squared plus 2x plus 1. That is a trinomial. You may need to use the factor box. Let's take a look. X squared plus 1 plus 2x, x times x plus 1x plus 1x is plus 2x. So that's x plus 1, x plus 1. Now what divides out? X plus 1 divided by x plus 1 is the same as 1 over 1. X minus 5 over x minus 5 is the same as 1 over 1. 6 divided by 3 is the same as 2 over 1. So what do I have left upstairs? 2 times x. What do I have downstairs? 1 times 1. Remember, that's a sideways 1 times x plus 1. And my result in dividing those algebraic fractions is 2x over x plus 1. Okay, our next question is to add two algebraic fractions. What do we have? 16. We have 3x plus 21 over 5x plus 10 plus 8x plus 1 over 5x plus 10. So you'll notice we have a common denominator. That's often our goal. We have the common denominator, so we're going to express this with that common denominator. We're going to express that with 5x plus 10. We take this piece plus this piece. So I have 3x plus 21 plus 8x plus 1, which will give me what? 3x plus 8x is 11x, plus 21 plus 1 is 22 over 5x plus 10. And you might think you're finished, but we can actually go ahead and reduce this fraction. If I factor out the 11 on top, I get 11 times x plus 2. And on the bottom I have 5x plus 10. I can factor out a 5. And I get 5 times x plus 2. And you'll notice that x plus 2 divided by x plus 2 is the same as 1 divided by 1. 11 times 1 is 11. 5 times 1 is 5. Upstairs is 11. Downstairs is 5. And that's our result. That one was relatively easy. Our next one is a bit more challenging. So let's take a look at number 17. That's going to require us to subtract. 17 is written as a over a minus 1 minus 2 over a squared minus 1. So how am I going to do this? I'm going to write it vertically instead. So a over a minus 1 minus 2 over a squared minus 1. Now what is a squared minus 1? Let's go ahead and do our factor box off to the side. A squared minus 1, middle term is 0. A times a, negative 1 times positive 1, negative 1a, positive 1a, a minus 1, a plus 1. So that's what a squared minus 1 is. It's a minus 1, a plus 1. Upstairs we just have a minus 1, and I have a here, and I have 2 here. So I want to build a common denominator, which will be a minus 1, a plus 1. Common denominator, a minus 1, a plus 1. Common denominator, a minus 1, a plus 1. I have the a that was there before, I have the 2 that was there before. Now I look to see what's new. A minus 1 was there before, a plus 1 is new on the bottom, so I've got to put an a plus 1 on the top. Nothing was new on the bottom here. So where are we now? I've built a common denominator. A times a is a squared, plus a times 1 is a, over a minus 1, a plus 1, minus 2 over a minus 1, a plus 1. So we have a common denominator. We can write it over that single denominator. And what do we get? A minus 1, a plus 1, a squared plus a minus 2. Now, can this be factored? Is that factorable? Well, let's go ahead and try to factor that. A squared plus a minus 2. What do we get? Here's a squared, here's minus 2, here's a. A times a plus 2 minus 1 plus 2a minus 1a is 1a. I think that's right. So we get a minus 1, a plus 2. So this becomes a minus 1, a plus 2 on top, a minus 1, a plus 1 on the bottom. And what happens? The a minus 1's divide out. A minus 1 divided by a minus 1 is the same as 1 over 1. And my final answer will be a plus 2 over a plus 1. Let's take a look at number 18. That requires us to solve for a variable. Number 18, we want to solve for b. We want to find b. And I have h equals rb over r plus b. Let's multiply both sides by r plus b. H times r plus b equals rb over r plus b times r plus b. The advantage, of course, of multiplying both sides by r plus b is the denominator goes away. So now I have h times r plus b equals rb, and we want to solve for b. Let's distribute. hr plus hb, hr plus hb equals rb. We've got to keep in mind what we're solving for. The question asked us to solve for b. We've got to get all the b's on the same side. So let's subtract hb from both sides. So I get hr is rb minus hb. So I get hr equals, let's factor out the b, capital R minus h, and then we finish this off by dividing both sides by r minus h. So I get hr, and that divides out. I get hr over r minus h equals b. And that will conclude this lesson.